Bismillahirrahmanirrahim. Good afternoon, everyone. Let's start with another lecture with another topic. Our topic today will talking about and explain important information about Pythagorean cup. This the form of this cup from the outside, and this the Pythagorean. Let's talk about the important information. I will start from the introduction and discuss how is the Pythagoras. And let's make appropriate definition to this man, this important man. Pythagoras was born at 500 BC, and his death was at the 585 in Samos, but resided for years in the southern town in Italy. That's mean he was Italian man. His parents named him Pythagoras. Let's discuss this point. Why his parents named him Pythagoras? It was a reason about that. Let's talk and explain what was the reason. The reason was the honoring the ancient prophet Pythia. That was something like God at the old ages. He is considered one of the most significant of ancient Greek philosophers and the same time mathematicians, founder of the Pythagorean school and father of the renowned mathematical theory. And let's don't forget the important thing, he has the amazing theory, the Pythagorean theory. A square plus b square equals c square. We take all this information at the prime school or high school. I can't remember. Yes, it first appeared in the 6th century BC. This cup was invented by the scientist Pythagoras, and he has the Pythagorean theory, like I said before. A square plus b square equals c square. Now let's talk about the other important information. The introduced was something like a presentation, something like present the old information about his life. Now let's talk about what was this cup and how he was depending on what, sorry, and which name was the famous one, and how much names belong to this amazing invented. Let's start the name of this cap. This cap has 3 names, but the famous one was the Pythagorean cap. You can write it at the Google map, a Google Scalar, or Google Academy, the same name. You will say too much information about it immediately. The number 1 was the Justice Cup, number 2, Grady Cup, and all of these names have a purpose. We will discuss this purpose together at the next slide. And the last one, and the important and the famous one at the same time, is Pythagorean Cup. Let's talk about and explain what is the Pythagorean Cup. What this amazing thing, why all of us interested about this invented. Let's give appropriate definition to this cup. Is a form of drinking cup which always the user to fill the cup with wine. Actually, most of them was use the cups to drinking the wine, because that I think this idea came to the Pythagoras and made his the amazing invention depending on this idea, because the users at the old age were too much. And I will explain all the important information to make this topic be clearer at the next slides. Wine up to a certain level. That means we have condition when we're dealing with cup like that. But like I said here, but has a condition. Let's talk and explanation or explain together what this condition. This, the normal cup. What that mean, normal cup? Normal cup, that mean I can use it to drink water or any another liquid because actually it is a normal cup. Why we using the cup? We're using the cup to put the liquid and other things and to using to drink. Uh, let's talk about what this line and let me explain. This show the limit, the condition to this cup. If you skip this level, you will facing think you sure you will not like it. Uh, That's mean we when dealing with this cup, we must be careful with this line, okay? And like we said here, this is the cross section. We have hole from this side at the middle of the column, and the column here at the center of this cup, and inside it the hole. Okay. Now let's explain what this figures. Pythagoras cup or siphon pump explanation. Here, this the core section to the Pythagorean cup. Here, it's empty like we seeing here. Here, when I put water or wine or anything, any another thing, any liquid, but with one important condition, the liquid must be with the same density. Water or wine or anything, another thing, but with the same density. And I will explain at the last of this lecture why. Here, I put the water here with this level, with this condition, without skip this level, I can drink my water properly. And like we see here, the water comes through from this hole to reach this level. And here, this point equal with the condition level. That's mean I'm safety now. After that, when I put more and more from the water, that's mean I'm ready now. We will dealing with another thing. The water can reach from this point to go to this hole to throw out from the cup, and after this siphon process, I will lose most of my liquid. Okay, and the remains amount will be just this simple things, simple level. Okay, and I will lose all of that. Like you can see my mouse moving, that's right. I will lose all this level. And we will discuss why not all of the liquid, why we didn't lost all the liquid, why we dealing with remaining amount. The same thing I will explain, I will answer this question at the last lecture. Now, let's say and discuss this cup dependent on what? Sure, he was amazing man, he was amazing scientist, but sure, he was a diagram to can made an amazing cup like that. Number one, hydrostatic process. It was the important element here because here, like we say here at all the three situations, we dealing with hydrostatic process, but here the hydrostatic process, it's not enough to lay the liquid to through from this hole. Here, with more water or liquid, doesn't matter, the hydrostatic process will be more. That's mean can lay to this liquid to throw from this hole to throw out from this cup. Here at the same second part, the hydrostatic process is not enough in the second cup and at the last cup. The hydrostatic process is not enough because that we dealing with remaining amount and not all the water or the liquid can throw out from this cup. And after that, with communication vessels theory. Here, like we're seeing here, we have many different figures, but the level of the liquid be the same. This phenomena, okay? Like I said before, hydrostatic pressure then creates a siphon through the central column, casing the enter content of the cup to be emitted through the hole at the bottom of the stem. Let's go to another slide to complete. The third thing was the Pythagorean cup works like the toilet working. Let me explain what the relation between the toilet and the Justice Cup. Let me explain to you here, like we're seeing here, we have two tanks here, the first one and the second one. The second one is smaller than, like we're seeing here, but here we're dealing with remaining water here at the bottom of the tank. At the same time, we know this remaining amount, what benefit to us, this prevent the bacteria from throughout to our bathroom. That's not our topic, let's skip it. And now let's come back to our topic. Here we're dealing with remaining water. Why this remaining water can't throw out from this point to out? Because the same reason, hydrostatic pressure is not enough to let this water to throw from this hole. But the situation will be different from when I push the button and let the water to dropping here, the hydrostatic pressure will be more, and that's mean will lead to the water to throw out from this hole. Because that I say the Pythagorean cup works like the toilet working, because at this slide, like when was discussing about the situations, the second one and the last one, the hydrostatic pressure was not enough at the second situation and at the last situation. When I put more of water or liquid at the cup and skip the level, I'm dealing with leaking liquid here. This the similarity between these two situations. And we can say like the giant storage tanks, because the giant storing tanks depending on the same thing, on the hydrostatic pressure, and by this phenomena we save more of money and prevent to spend more of electric power. Here, like I said before, we're dealing with this hole, and we're dealing with the pressure here, electrostatic pressure, and here the liquid reach this point, but here can throw out from this column. Here I will use this figure at the conclusion part to discuss another thing. When we dealing with two kind of liquids, I mean two kinds of liquid, but have difference of density, what will happen? Can this water throw out from this hole if the red space B has more density from the water, for example? What would happen? Let's think about that to can solve this question together. If I put more pressure, what will happen? If I dealing with the normal condition, what will happen? If this water can through from this hole to outside by using this column. Now, why it last figure not all the liquid is drained? Like I said before, because the hydrostatic pressure is was not enough to let this remaining amount to through from this column to outside. Now, the purpose from all that. Sure, scientists like that always has purpose when he made everything. Let's discuss what the purpose from the Justice Cup. To punish the avid, the great, and facing one of the vituperation principle. Pythagoras teaches us to accept what we already have and not ask for more and more. That's the similarity between, for what I'm talking about, and the Justice Cup. When we put more from the water, juice, or anything, another thing, what will happen? We must accept our rights and keep going. The keys to heaven and hell. To when we accept our right and keep going to make our be better. I think this is the story. This will be the keys to heaven and let us be far away from the hell. And the last thing, I think to test his student, because like I said before, with the situation, what will happen? It's important and different and difficult at the same time. I can make many questions from this figure by change the conditions, the pressure, or change the density. And I can change the density here by putting liquid has more density, more than the upper, or change the situation, okay, to test his student. Now, the last slide of summary, he was depending on siphon pump law, like I said before, to finish the greedy. The Justice Cup is interesting cup until now. That's great, that's right. Now let's talk about the conclusion. He made it to test his student. Like I said here, if we put liquid has density more than the water, if we put the water, if the water is the upper at this cup, what will happen? If this water can throw out from this column to outside, if we're dealing with leaking situation or what? By makes them think about the explanation of this phenomena. I think he was another purpose. That's just my opinion. He wanted to appear scientists have a sense of humor, not just like a machine just working in the lab and just thinking and thinking and thinking. There is one condition to let this experiment works. This is very important. Like I said before, we must dealing with liquid have the same density, or we can say the same type. That will be clear, more clear to us. If we're using different types of liquid, what will happen? Here, we use the mercury here. Let me show that. If we put the mercury heat here at the bottom of this cup, and after that, dropping water to be upper of this cup, what will happen? Here, like we say, because we're dealing with hydrostatic pressure, the mercury will reach this point. This point, you know what this point will show to us. This is the level, this is the condition. If we cross this or skip this limit, we must facing with leaking here from this column, from this hole. But here, we put more and more of water up this cup and cross the condition, cross the limit, but Until now, we don't facing with leaking situation. Why? Because the mercury has density more than the water. By this situation, the density, the more this density to the mercury here, don't let the water to throw out from this hole, can't push this amount of liquid from the mercury to kind of through from this column to throw out to let the water to let space, appropriate space to this water to kind of throw out from this cup and dealing with leaking situation. But all these dealing with normal condition. If I'm dealing with the same situation with the mercury has the more than density from water, and I want from the water, I want make this water through from this point, from this hole, from this column to outside. What I must do? Like I thinking we must push, we must make the hydrostatic pressure be more and more to can push this water to let the water has the enough strong storage, enough energy, enough storage to push the mercury from this point to throw out from this hole, and after that immediately the water can through from this point if can still cross this condition, this level, to throw out from this cup. The answer, like I said before, will depend on the density of the liquid. And we can do another track. If we make the hydrostatic pressure be more and more, we will let the water throughout from this cup, like I said before. The research, actually, I depended on, let me show, no, not this. I depended on this article. It was amazing. And at the same time, we're dealing from these two websites. Thank you about your watching. Thank you about your patience. I will see you at the next lecture. Kendinize bakın. Gelecek derste görüşürüz. Let me stop the recording from this button.